So your DigiID has feature values that are identified, and then those feature values are found inside something called Geomancer Geospatial. Those features can be anything, your weight, distance, etc.
We're going to Google feature values, machine learning. And we're going to click on the Wikipedia page. In machine learning and pattern recognition, a feature is an individual measurable property or characteristic of a phenomenon. That's because they want to change something around you. Every time someone accesses your body, the features values that they accessed and whatever it is that they were looking for are kept in something called a spellbook. So when they are connecting the data warehouses with Geomancer to look at you and figure out where you are, the other thing they will do is open up a spellbook. When it does that, it wants to coordinate the extraction of geospatial feature values. For example, how many supermarkets within your radius? How far to the nearest mall? Whatever it is that it's looking for. Again, a phenomenon or a measurable property. Now we're going to go look at this link. Geomancer, automate extraction of geospatial features. November 2022. As of now, again, in November of 2022, as of now, there is no development in Geomancer, and we archive the repository. I've recently changed jobs too, as I am working in open source, full-time, with Explosion and Spacey. You can check out my retrospective at the end. Last Tuesday, I gave a talk at Database Manila at the Asian Institute of Management about Geomancer, an open source library that I helped build. So I figured it's best to talk about the project through my slides and give a deeper context to some of the library's design. Geospatial data at scale with Geomancer. Why build Geomancer? Through some of our geospatial client work, we saw how informative a single coordinate could be. When taken together, we can extract patterns that can help us with tasks like wealth estimation, building detection, and hub estimation. However, significant prerequisite involves getting useful machine learning features to train statistical models. A single coordinate is already packed with a wealth of information. For example, how many supermarkets within a 1.5-kilometer radius? How far is the nearest mall? How frequent do traffic jams occur around me? And more. Feature engineering is a common task in machine learning. It involves transforming raw data into features that data scientists can use for statistical learning techniques. Unfortunately, there is no easy way to do these as of late. Most require extensive knowledge of geospatial tools like QGIS or ArcGIS. These techniques also don't work well at scale. Workflows can be complicated and costly in compute and storage. Geomancer aims to bridge that gap by providing a Python library and a framework to set up a geospatial feature engineering system. We built a tool called Geomancer to help us do feature engineering at scale. What can Geomancer do? Geomancer allows users to quickly define features, connect multiple data warehouses, and share or reproduce features. For example, data scientists need only to interact with Geomancer Python library, while data engineers set up the backend connection to the data warehouse. Given a set of lat-long coordinates, users define a spell to create features declaratively. These are the building blocks of the library. For example, a spell can be a distance to the nearest point of interest, the number of points of interest within a set length, and more. Geomancer allows us to define features easily. So first, you define your spells, your features, the phenomenon you want to change around your target, and or the feature values of measurements like heart rate, signal, bank account, ledger system, whatever. And then anybody who has polled, P-O-L-L-E-D, those biosignals and bioinformatic feature value data. That goes into your spell book. And then the next person that comes up can compare and contrast the changes in you since then. Geomancer allows us to share and reproduce our features. Save your spells and share it to the wizards near you. For example, keeps a record of our most important features. Feature reproducibility. Use others' features to our own data set.
So maybe people will put attention on a hat, a wizard hat.
Yeah, I mean, what are the odds that they define your spells and put it in something called a spell book?
Mm-hmm.
And if you look at the images, it is a wizard and a wizard hat. And as we just read, it said, where was it? Save your spells and share it to wizards near you. So these engineers that work these jobs, they even call them wizards.
So now, if we go here, Geomancer, an open source framework for geospatial feature engineering. And we look at this image, there's raw coordinates, reference data sets, and derived feature values. These feature values are part of your digital identifier. For those who are interested, I suggest you read the entire PDF file. There is lots of information on Geomancer, geospatial, feature engineering.